Hi everyone, very good evening. Welcome back to Geeks for Geeks. Today we have another DSA mock interview. Our guest for today is Anirudh. So we'll be interviewing him. He has solved a lot of questions on Geeks for Geeks. That is one thing that I found out in his resume. So I'll be asking him two or three questions in a span of 1 hour. So all of you can quickly give me a +1 in the chat if my voice is clearly audible and everything is working fine so that I can call the guest for today. All of you can quickly hit the like button and give us a +1 in the chat so that I can see that everything is working fine and we can start with the interview. Okay, so let's call our guest for today. Hi, Anirudh.
Hello.
Can you please introduce yourself to the audience?
Sure. So my name is Anirudh Semwal, and I am a third year BTech student at Graphic Era Hill University, Dehradun. And talking about my coding profiles, I have solved a lot of problems on Geeks for Geeks, about 550, more than 550 problems, and about 150 problems on Lead Code as well. And I have participated in a lot of contests on Geek for Geeks and Lead Code. And recently, I have also started doing Code Chef and Code Forces.
That is also reflecting on your t-shirt. As you were saying 500 problems, I
Yeah,
understand that you have solved a lot of PODs and you've got this t-shirt as well.
yeah,
Okay,
yeah,
so
yeah.
great. And you, okay, great. How much excited are you for this interview?
I'm very excited for this interview.
And how much you will rate yourself in terms of DSA? On a scale of 10?
Uh, I would rate myself a 7 out of 10.
Okay, great. So as you know, I'll be interviewing you for around 45 minutes to 1 hour, and I'll be asking you two or three questions. If you solve two questions quickly, then I'll be asking you a third question as well. That depends on the time stamp, but you can quickly share your screen so that we can start with the interview for now. And all of you can hit the like button, guys, so that we can have a head start. Okay. So you have shared your screen.
Is
Great.
my screen visible to
So
you?
now, yes, your screen is visible to me. Just give me a second. Okay, so if you will look in the private chat, so I have shared a question link with you.
Okay.
Have a look. Okay, so you can reset this code now. You can reset this code. Actually, I know that you have solved it. So, okay, so since you have solved it now, so let's do one thing. Let's change the question. Since you
Okay.
have solved it already. Okay, so just give me a second. Um, what I'll be doing here is, okay, let's see if you have solved this one or not. So if you will look at the private chat now, so I've shared another question with you. Okay, so let's start off with this question for now. So in this question, what I'll be giving you is, I'll be giving you an array that will consist of n integers, and I'll give you like a constraint. So your task is to find the maximum value of j minus I such that this constraint is being followed. And the constraint in this part is that a of I should be lesser equal to a of j and I should be lesser equal to j. So following this constraint, you have to find the maximum value of j minus I. If you will look at the first example, so n is equal to 2 is given, so two elements are given in the array. The first element is 1, the second element is 2. So obviously if you will see, so I will be standing at 1, and like I will be standing at the index 0, that is nothing but the element 1, and j will be standing at the second index, that is nothing but the 0 in j is equal to 1, basically the second element, and in that case a of j will be 10. So you can see that a of j is greater, a of I is lesser equal to a of j, that constraint is being also completed, and I is lesser equal to j, that is also completed. Right. Now, if you will scroll down for the second example as well, so let's have a look at the second example. Yeah, you can scroll down. Yeah. So in this case also, you will see that I have to find the maximum value of j minus I. Correct. So in this case, if you will observe, so the maximum value of j minus I will be, when it will be, in this case, it is nothing but, so you can see that it will be, I think it will be in this case when I is standing, I think at basically for I is equal to 1 and j is equal to 7, you can see that this constraint will be followed. Okay, so is this question clear to you? Pretty much very simple and straightforward, to be honest.
Smaller than a of, in this case, we are considering 8 and 33. Okay, let
Yeah,
me read a question once again. Given an array of n positive integers, also find the maximum j minus I is exactly constant. Okay, e of I should be less
you
than
have to
equal to e
find
of
the
j, and I
max.
should also be
But if
okay.
I is lesser equal to j, in that case, it will, like, if I and j are the same point, then you will have zero. No, maximum will be zero.
Yeah, yeah, yeah,
So basically, uh, I hope that you are clear with the question. Basically, you have to find
yeah, yeah,
like
yeah,
the maximum value of j minus I says that the conditions hold that I should be lesser equal to j, and a of I should be lesser equal to a of j. I hope that you must have solved some questions like this based on indexing and maybe something like that.
yeah, 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 yeah.
So,
Okay,
what comes to your mind?
okay. I can start if I take 34. Let's say I'm started the 0th index, then I have to find the index which is greater than this. One thing I can do is that mm, the brute force uh, approach that comes to my mind is I'll check for every index uh, and find the index and find the element that is greater than this, and then subtract the indexes of both these elements and store the maximum of all the elements out of these.
So you are saying you will use nested loops.
Yeah, yeah, yeah. I'll use nested loop, and the time complexity will be big of n square.
Okay. Can you think of something more optimal than that?
Yeah. Can I solve this on paper?
Also, yes, you can solve it on paper as well. But whatever you are thinking, you can think out loud so that we also know that what you are thinking,
Okay,
and
okay,
I can
sure.
give you relevant hints. So, like as you are writing it on the board, so you can keep on explaining because we can always see the example, whichever example you are
Okay,
taking.
okay, okay. If I take the second example, and currently I'm here. So j minus when the maximum j minus I should be maximum, and the ith element should be smaller than the jth element. So can I say
It can
that
be lesser
I'm
equal
here?
to.
Yeah, 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 less than equal to. So I'll check for this. If for every element I find the uh, say for next greater element one, it's nothing. It is nothing. 30. It is nothing, and nothing. 80. 30. It is 33.
Um,
It is thing, and for 32.
Guys, all of you can hit the like button and give us a +1 if you are clear with this question as well. And you can, in the meanwhile, I'm looking at the chat, so you can tell us about your approach.
To solve this, uh, for every element we have to find the element that is greater than this element, greater than or equal to this element, which is ahead of this element in the array. So uh, I cannot sort the array. What can I do that I have this element, and it for, say we are at index 0, so the element we have to find that is greater than this element. uh, can we keep track of the small element 34 and 8? So for 34 we can find greater element, but let's say 34 and 1. If I have 34, so if I neglect this, how will this be happen?
Like whatever comes to mind, you can think out loud.
Okay, if I consider the smallest element that I find, but it can be the case that there is some element greater than 30, greater than 34, that might contribute to our answer, and which can make a larger value of j minus I. So I cannot neglect 34 as well.
Correct.
So
And why were you thinking of neglecting?
because if we find an element smaller than 34, then it can contribute to the answer, but still there can be an element that is greater than 34 at the last position, so neglecting 34 will not make sense in this case.
You were thinking of 2 pointers basically.
Yeah, I was thinking of kind of that. How will this happen? 34, 8, and it's currently we are at 34. We cannot. Um, I have to see something that is 34. Then if we traverse from back, can we find something? Let's say we have 1, and it can't be. Then we have 33, and 34 and 33, uh, 8 and 33, 0, 1, 2, 3, 4, 5, 6, 6. Okay, what if there is 2? If we traverse from back, like our I pointer will be here, and j pointer will be here. So like 34 is greater than 1. So if we neglect 1 and come to 33, no, then we will have to neglect 33 as well. This will not
Yes, you
give
will
us
have to
the
neglect
answer.
33.
But then it will not give the correct answer, no, because we have to consider 33 in this case. So 34. But if we neglect 34 and 1, then we will have to neglect 8 as well. So, 4. Can I use something like stack or
You can use whatever you like for this question.
yeah. But uh, I have 34. Just
You're
4.
thinking in direction of next greater element.
Yeah. I'm thinking something like that, but I don't think it will work.
Okay.
34 and then 8 for next greater element. 1, mm,
Uh,
1, 33, 30, and I have to store 80. Every next store the next greater element. This also will not work. This will not work. Stack will not work. So I'll have to think of something else. Uh, 34. Why can't we do this? 8 for 34 we are making 34 and 80 is a pair, but we are neglecting this and taking 8 and 33. But how will we do this? 34 and 80. Let's say we are at 34. We'll come to 8 and 8, and then we come to 10. How will this work?
You can take your time. You can, like, it's not necessary that you directly come to the optimal approach. You can think about something, maybe why you search, maybe something else, then maybe you can get some intuition, maybe in some way or the other finding some kind of maximum or something.
Some kind of maximum 33, 34 we can find. Okay, okay, suppose if I take 34 and start finding maximum and start finding the element which is greater than this from the back,
Okay.
that is, and then we will reach to 80. For 8, if I start traversing from back, I'll get 33. But still, uh, and for 10, how much time will this take? For 10, it is again 33. 10, that element that is greater than 10, it will be greater than
Mhm.
8. So I will not have to, if I do this, how much time will this take? Yes, 8 in this. Can I do like this, that I'll start traversing from the 0th index and start finding the element that is greater than it from the back of the array. Like for 34, I'll check for 1, 33, 30, and 80. 80 is the first element that
Okay.
is greater than 34. So our answer, currently our answer will be 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. Currently our answer will be like how much will this, 0, 0, 1, 2, 3, 4, 5, 5. And for 8, I'll start traversing from can I store the maximum, can I store the maximum from the back, can I store some maximum, like I have 1 and
Okay.
33, and 30 is not the element, but it can be greater for some element, so I cannot neglect this as well. For 8, for 10, I'll element that is greater than 10, it surely be greater than 3, 2. Finding some kind of maximum, to find the maximum uh, for every index. 34, 34 I'm at 1. Can I do it like this, that I'll start from, like I'll take I as the 0th index and start searching for the element that is greater than it from the back, and for 34, the element that is greater than it will be 80, so the answer will be 5. And for 8, I'll start checking from the back again, and and 33 will be the first element that is greater than it, so our answer will be updated to 6. So currently our answer will be 6. And for 10, we will search up to 33 only, because uh, because 10 is greater than 8, and any element that is and because there is no point in searching beyond 33, because we already have answer that is greater than the distance between 10 and this 10 and 33. Are you
Okay.
getting my point?
Yes, a little bit I'm getting your point.
And for 3, 8 for 1, 2, 3, and for these uh, we don't have to search, and we can ignore for other indexes, because even if we find any element at the back of the array, still the length will not be greater than 6, because currently our answer is 6. So for this case it is working, but will it work for every other case or not? Like
If you
I'll
want,
start searching for, sorry.
if you want, you can think about any other test cases. If you want to think about any other random test cases also, you can think about that, and you can tell us
8,
about that as well.
8, 4, 10, 8, 4, 10, 12, 3, 9, 7, 5. Okay, let's say we have an array. Uh, we have an array 8, 8, 4, 10, 12, 3, 9, 7, 5. If I for 8, I'll search for an element from the back that can be greater than 8. So 9 is the element. So the
Okay,
length becomes 5. And for 4, I'll start searching from here. I'll search for only that much indexes where the length is greater than our previous answer. Like for 4, let's say there would be 3. If 3 were here, then I would not search beyond 3, because already we have length that is greater than the difference of these two numbers, the length of these two numbers. So I would not search for beyond the last index for 4. No, but if
okay,
it will happen it will happen only if we have found our answer. If we have not found our answer, let's say
if
here
you
is
have not
2,
found, then
we have 15. So 15, for 15 uh, we will have to traverse through every index. If the array is in decreasing order, then it will take off and square. So this approach also won't work, because it will take off and square in worst case.
okay. Can you think
So
of something more?
how to use space? uh, 8, 10, 20, 30. For 34, we will have to find the element that is greater than greater than or equal to. So the element that will be greater than 34, if I start traversing from the back, 34 and 33, 30, 80. How will this happen?
Okay. Let's think about it a bit more. Like, you think like anything that can work, like any, like
Uh,
you have to find, no? You have to find. So like you are thinking about always n square. Maybe let's say n log n. Can you think of n log n?
and log n.
And if I
Okay.
say n log n, if I say n log n at least, then that's also a big hint.
Yeah, yeah, yeah. It's a big hint, but binary search. But now let's see, for 34, I have to find which is greater than this. Can I think something like prefix sum? Can I think
Okay.
34, 8, 8, 4, 12, 42, 52, 55, 57, and 57 137, 167. Can I think of something like prefix sum? Okay, so now I have 34 and prefix sum, and then
Are you
can I
exactly
apply
saying
binary
prefix sum
search?
or prefix sum technique?
Prefix sum, and by using binary search on after that, I'm thinking something like
Okay.
that.
Okay.
But how to do this? Uh, 34. So I'm saying 34, and
Um,
fix some how to use this here. Uh, 8 4
you don't need to take much pressure. You can just think lightly about it. Like,
I have to search for element that is greater than 34, greater than or equal to 34 from this array. But how will this prefix sum help me in doing this?
why? Like you are saying prefix sum always. Like, mm, are you sure prefix sum is going to be used? See,
I'm
have you ever
thinking
done
in
a
that
question?
direction.
Okay, let's say I gave you a question. Let's say I gave you a basic question that you must have solved. That array of I is there, and array of two elements such that array of I plus array of j is equal to some target. Maybe you do
Yeah.
bind search on that on the array, and maybe you can do it, right? Correct.
What
So here,
what is the question?
maybe here, like see, if I give you a basic question, array
Yeah.
of I plus array of j, two indexes such that array of I plus array of j is let's say equal to the target. You can do that kind of
Yeah.
question using maybe binary search also. Maybe binary search, although there
Yeah.
are
Yeah.
better approaches, but maybe you can use binary search also. But can you apply something like that here? And if yes, then how? Like, what will you try to do binary? Like, if you are thinking, let's say in binary search direction, maybe, then in that case, how you will think about, because if I give you this thing, na, array of I plus array of j is equal to some target, then you try to search for
Yeah. Yeah.
something, na. So
Yeah.
here also you have to search for a particular thing. So what will that be if you are maybe thinking of searching?
I'm searching for something.
Because see, if order of n square loop also you were maybe searching for something,
Yeah.
correct? But it was a very brute approach, because you were searching
Yeah.
for your
Yeah.
jth element, na, that satisfied the condition.
Yeah. Yeah.
So maybe you can think of something.
Something using binary search.
Yeah, let's say something using maybe n log n binary search.
Uh, how to do this thing using binary search? The element. Okay, any element that is greater than, but for that the array has to be sorted. How to do this? Uh, I have to search among these elements. The array is sorted. No,
Okay, let's say
the element that
I
is.
give you one more leverage in this question. Let's say what I
Okay.
ask you, like let's say I tell you that you can use a data structure. Let's say another hint that I can give you is, let's say you can use maybe something like a hash map or something. Let's say, if you want.
Okay. Any element that is.
Meanwhile, I'm also looking for the second question that I should ask you, because I'm thinking
Okay.
you might have solved something.
Hash map. Let's do this. And let's do this in the map. How will this 8 and 33? that is greater than. If I store the indices, uh, if I store in the like 34, map of 34 equal to 0 and map of 8 equal to 1. How will
Okay.
this work? Mm, 8, then this and I'll keep on. Okay, 10. Can I say that let's say I keep on storing these values. uh, let's say map of 0 I stored at 34 and map of 1 I stored as 8, and I kept on doing this. So I'll have to search that if this map contains any value smaller than the current index. If it contains the value smaller than the current index, then I can find the difference between this index and the index at which that value is stored. Let's say 2 is 10, map of 3 is, yeah, like, no, but how, like map of 0 is 34, map of at the first index there is 8.
But maybe you were thinking something correctly in terms of prefix also, but not exactly. Like you were
Okay.
very close to it, I will say, but not the prefix sound, but somehow or the other maybe prefix technique you can use.
Yeah, that I can store the prefixum in the indices of the map. It can be something like that. uh, 34.
Why do you get an intuition of using a prefix sound?
I don't know. I just it just came to my mind. Because I think
Okay.
it requires something like this. Because we are searching for using one element, we are searching for other element that is related to it.
Correct.
But
Okay, let's say if I allow you to sort the array as well, then can you tell me something? And I've said hashing
if
as
the
well.
array if the array is
If
sorted,
I
then
allow you, if I allow you to sort the array as well.
okay. So if the array is sorted, then the answer would be obviously the last element minus
No,
the
no,
first element.
the array will not be sorted. I'm asking that, I'm saying that you can sort the array as well, let's say, for your
Okay,
simplicity.
okay,
If you,
okay, okay, okay.
maybe now you can think of something. And but if you sort the array, then you will have to take care of the actual indexes, correct? Are you
Yeah,
getting
yeah,
my
yeah,
point?
yeah, yeah, yeah.
At least this much I was expecting from you, that maybe if I have said hash map as well, you could have said the same, but fine. Now I think you will come close to the solution.
Okay, if I sort the array, then I'll have to store
Then you
the
have to
ind
take care of the indexes.
yeah, yeah. I'll have to take care of the indexes as well while sorting this array. So
Maybe that thing you can do in a, let's say, hash map. But once you do that, then what will you do? Even then, even if you have hashed the original indexes for the particular element and you have sorted the array, now everything is a freedom for you.
And, so if the array is sorted, then we have to find an element that is uh, whose which is greater than the current element, and whose index is also greater than the index of the current element in the array, in the sorted array or hash, whatever we store our value in. So the first element is 1 and its index is 8. So we have to find an element that is we have to find an element that is greater than 1, but that's not the case. It's not. uh, that is, can we do something? It's not. It is greater than, but then it's not greater than.
Shall we move to the new question, to another question, or you
Yeah,
want some more time to think?
I think we should move to the next question.
Okay, let's move to the next question. No worries. Let's move to the next question, guys. So if you will look at the private chat now, so just let me know if you are able to access this or not. Okay,
Yeah.
so let's discuss this question. Now, basically, what data structure it is, as we all know, it's a tree. Now, what have I given you? So I want to find the maximum sum of non-adjacent nodes. Okay. Now, what is a node? A node is something that has a left and a right child and all that stuff. You already know this. But I am asking you to find the maximum sum of non-adjacent node. So basically, I'll give you a binary tree, okay, with value associated with every node. So every node will have some data in it. Okay. And we need to choose a subset of those nodes. Okay. Like if I give you an array and I ask you to, let's say, if I give you an array, I ask you to find the maximum sum of non-adjacent elements. You do that now in array also, where two elements are not adjacent. So in this case also, I'll give you a binary tree, and what you have to do is you have to find a subset of those nodes. You have to choose some of the nodes, and you have to choose these nodes in such a way such that the sum of the nodes that you have chosen is maximum possible. Given that you should follow the constraint that no two chosen nodes should be adjacent to each other. No two nodes that you have chosen in the subset should be adjacent to each other. Nodes should, if they are adjacent, then it will not be considered as a maximum sum. So we need to take care of this thing, and you have to do this. So is this question clear? That you have to find the maximum sum of the non-adjacent nodes. So you have to choose some nodes. Like I've given you a set of nodes. You have to choose some of the nodes in such a way such that the sum is the maximum possible, and no two nodes should be adjacent. So if I give you 11, 1 and 2, so you can see that the maximum sum will be 11, because if I choose 11, then I cannot choose 1 or 2. Correct. But if I chose 1, then I can choose 2 only. So, but that sum is 3. So the maximum sum here is 11 only. If you see for the other case also, so in that case, if you observe for the second case, that is 1, 2, 3, what is the case here? 1, 2, 3, 4, 5, 6. So in this case also, you can see that you will choose the node 1, 4, 5, and 6, because you will not choose 2. Like if you choose 1, then you will not choose 2 and 3. Then maybe you can choose 4, 5, and 6. So the total sum that you will get is 16. Here also the sum of the uh, no, like sum of the nodes is maximum, and no node is adjacent to each other. So if the audience is also clear with this question, so they can write a clear in the chat. And also, guys, I can see that the number of people watching are more, and the likes compared are lesser. So make sure to hit the like button if you're watching till now. This is also a very interesting question, and I hope that uh, Anirudh will be able to come up to a solution for it. So Anirudh, is this question clear to you, or you want some more clarity
Yeah,
on
yeah,
it?
yeah,
I hope.
yeah. It is clear to me.
Okay.
Okay. So the question that is given to us is like, if we pick any child node, then we cannot pick the parent of that node, right?
If you take any, let's say, yeah, vice versa. If you take any parent, then you cannot take in the both the children.
Yeah,
If you
yeah,
take any
yeah,
child,
yeah, yeah,
then you
yeah,
cannot take the.
yeah, yeah.
Correct. You are saying the right
So
thing
we can,
as of now.
yeah. So what will we do? We will start from the leaf nodes, and we will maintain a state that if we have picked this, then we will not pick their parent, and if we have not picked, then we will pick the parent node of that child. And uh,
Okay. So you are thinking in
this,
terms of DP.
no, I'm not thinking in terms of DP, but
Okay. So you are saying in terms of parameter, you will say that you have picked up
yeah,
somebody
yeah,
or
yeah,
not picked somebody.
yeah, yeah, yeah,
In the next
yeah.
call, you will
I'm
tell,
thinking,
like, you will have some parameter that will tell you that you have picked somebody in the
yeah,
previous call or not. Okay.
yeah, yeah, yeah. And I'll compare that in which case I'm getting the answer as as a higher value, that in case of picking that element or in case of not picking that element. This approach comes to my mind for now. Let's
Let's say if I've given you the root, then how will you continue the further process for it in terms of code, in terms of thought process?
okay, okay,
Uh,
let me do it.
and you have
Yes.
like you did not ask me one question that I was expecting. So
Yeah,
see,
what?
if do you think that you must have asked some question? Yes, you should have asked one question more. So in this, I'm giving you the notes. All the notes data will be greater equal to one. Is that clear to you? If it would have been
Greater
negative,
than
then
equal to
things would have been different.
okay, okay,
I'm giving you all the data as positive. All the nodes will have positive
okay,
data
okay,
only.
okay, okay. Positive value. Okay, 5 6 if I send.
If you want, you
Okay,
can
I'm currently
write the code along with it also.
okay. Currently, I'm drawing the tree and on my copy and writing the approaches, writing the parameters that I said, that what will be the case if I pick this and not, and if I do not pick this, and I'll write the code after that. Okay.
But you can keep on explaining us
Like,
about your thought process.
yeah, yeah, yeah. If I pick four, and if I pick four, then I'll send. Let's say I send the parameter as one, that I have picked four. That I have picked four. Okay. And in that case, I cannot pick two. I cannot pick two, and you cannot pick two, and our sum will be four. Our sum will be four, and if I pick two, say I say pick, and no pick. I'll have to do this. I think. Uh, say I have root, and if I'm picking any node, I'll send the parameter to its parent as one. I'll send as one that I have picked that node. In that case, I cannot pick its parent. In that case, I cannot pick its parent, and parent. Okay, let me type the code and let's see what happens. Okay, I'll make another function for this. If root is null, I'll return zero, and uh, root is null, I'll return zero. And what if I pick? I'll,
So as of now, you have passed only one parameter, that is just the root.
yeah, 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 yeah. Uh, picked.
Even if you think in terms of, let's say, very basic, it can be right or it can be wrong. But when you're at a particular node, maybe you can maybe pick it, not pick it. Maybe if you think of this fashion or something else.
Yeah. At every node, if I pick it and not, yeah, I was thinking like that. If I pick
Maybe
it,
it can be wrong or it can be right, but at least you can think of this.
yeah, I think that's what we have to do. That at every node, either we will pick it or not pick it. And if we pick it, then the node at the next
Yeah,
level will not be picked. And if we do not pick this, the
basically the
node at the
children.
next level will. Yeah. Okay. So you are saying me to traverse in the top to down fashion.
You can traverse as like in
Yeah,
whatever
I can
fashion
traverse
you
in
like.
that.
Basically,
Mm-mm.
if you go bottom up, that will be in the backtracking process in terms of you can say what it will be post order traversal if you're talking about processing the route later on.
So let's say that if it is, uh, if I pick this, okay, pick and not pick. If I pick four, if I pick four, in this case it will be four. And if I do not pick this, yeah, it will be. It has to be something like this. Uh, so the pick, will be my second parameter, and this will show that have I picked the last element or not. So currently I have not picked the last element.
Okay.
I have not picked the last element. So what will I do? And I'll do from bottom to top. Uh, like roots left. You know what I'm doing there. Root left. Okay. Roots until it is having its left. So it is having. So if I go down the tree, uh, the pick value will not change because I will pick while I'm coming up, so it will remain as it is. And I'll say pick equal to 0. No, I'll have to make, let's say I call it as last.
But do you need to pass it by ampersand even if you're taking a pick variable? Do you need to pass it by ampersand?
If last equal to 0, that is we have not picked the last. So
Then you can pick this guy.
yeah, then I can pick this guy. Plus equal to root data, and no pick. Then I pick. Then I can pick this, and otherwise I cannot pick this. So it will happen that if I pick this, it will be 4, and at this level it will be 4, and uh, data, and okay. And what if I do this in? What if I do this in top to bottom fashion? If last is equal to 0, I can pick and f root left,
Okay.
comma, not of last, not of last. And similarly for last. And if last is 1, that is uh, we have picked the other. So no pick, no pick equal to no pick will be equal to uh, wait, 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 wait. If the last is 0, that is we have not picked the guy at the, if last is 0, then we can pick this and send this, and to the next level. But if the last is 1, that is we have picked the guy above this level, so we cannot pick uh, last is 0. If last is equal to 0, then plus equal to root data, and else if last is equal to 0.
If you have not picked the last guy, if you have not, basically, if you have not, you are saying that if you have not picked your parent, then you will pick the child. Correct? That is
Yeah,
what you are
then I'll
saying.
pick the child. Yeah.
That is what you are saying in the if statement as of now, I can see. And if you have not picked
If
the parent, like, no, if you have picked the parent, then you will not pick the child. You are saying this?
if I have not picked the parent, then I'll pick the child, and if I have picked the parent, then I will not pick the child, and if I have not picked the parent, then I'll pick the child. So, but how to do this? That
So
if
initially
last is one,
you
that
have
is,
passed what? Initially you have passed what in the main function? Can you scroll down? Okay, so you have passed 0. So you are saying that
yeah,
you are saying that initially you will try to pick the root, or you will not try to pick the root. You will
yeah,
try to pick the root,
yeah. I'll
but
pick
you
the
can
root.
also but you can also skip it now. How will you cover that
Yeah. I can
case?
also skip this.
Mm. But are you covering that case in your code?
Yeah. I will have to. I'll have to call another function. This function one more time by sending one. I This can be done in
Okay.
this way, that if I send pick as one, then that will cover the case when I do not pick the root. And if root is not, let's say if I return 0, and pick is 0, pick is 0. If the last guy is 0, if the last is 0, that is I have not picked the node before this level, then I can pick the data of the root, then I can pick the root, and I'll send uh, in, but
Guys, we are
these guys also
very close to the end, guys. So all of you just make sure to hit the like. I can see a lot of people are watching us. So if you are new, if you have just joined, so make sure to hit the like, guys. Make sure to hit the like button.
is
We
0.
are almost about to end it
But how to
in some time.
do this that?
See, as of
Last
now,
equal
if
equal to
you
0 in that time. But if
even if you don't think about getting a wrong or right, but still, if you're thinking at least this much, then still you can complete your else statement.
yeah, I'm thinking about that what to write in case of no pick, because if I have not picked the last level, then I'll pick the root,
Then you will pick it, and you
and
for the children you will pass
yeah,
that you should not pick them.
I should not pick them. But
You are passing it as a
and if
parameter that you
last
should
is
not.
1, yeah, and if last is 1, then I'll keep pick as 0. But if last is 1, then I'll keep pick as 0, and shall I send root
But there's one more mistake that you are doing now.
to 1?
See, one more mistake that you are doing in the line number 118 and 119. The mistake that you are doing is those functions are returning some values now. But where are you
That
storing
that
them? If they are returning, like, are you wasting them? Like, are you getting this part?
yeah. I was also thinking about that. That's what I'm thinking. That how will I store? If I make this function as void, uh, but how to use this no pick variable? That if the last variable is zero, then I'm picking the current root, the current root,
Okay.
and sending to the next level. That we should not pick the element at that level. And if the last is one, if the last is one, that is we should not pick at this level. If the last is one, then we should not pick this element. The last is one, then we should not pick this element. So uh, pick, no. I think we should not. I think we do not need this. And I can I can do like int answer one. I'm keeping answer one as that. If I pick the root, can I do it? Can I do it like this? And I'll make this as I
How
make
much
this as
time will
void.
take? Like from here, if I say that you have written almost a skeleton code, so how much time you will take for writing, let's say, a working code for it?
I think not more than 5 minutes.
In that case, we are tight on time. But if you want, still you can try it out until we reach the end.
Okay, so in answer one, this will be answer one plus equal to root data. That if I pick this, and if last is zero, and uh, I will not take this, and the other case that if I make it as
See,
one,
that part we understand. This much
answer
part we
two as
understand that you will
uh,
have answer.
yeah, yeah,
Uh,
and
there's
I'll
no
return
issue
the
with that.
maximum of the both answer one and answer two.
But the thing is, how will you calculate the function? Like, how will your function be calculating such that you get optimal answers in those functions? That is the main challenge that
Okay,
is
so
in front of us.
for the case in which I am taking the root, this case I say that I have not picked the last element. So I have not picked the last element. So I'll pick the root. I'll pick one, and I will not pick these two guys. So I think this will work in this way that firstly I'll pick one, then my value will be uh, one. Then I'll go to the left of this, that is two, and it will not pick this value. And I'll say else I'll send the values as that is not no that is zero, that I have not picked at this element, and I can pick at the other uh, I can pick at the other level.
Correct, 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 correct.
And this way, and I can directly send zero, so I can directly send one here. I think this will work.
You want to compile it at least for the samples? You
Okay,
can.
okay. Two, pick and answer two, and answer okay. Okay, let me check if pick is zero and answer one is zero. I'm sending this to like, answer one is root data, and if last is not zero, then I'll send to other guy. If root is null, I'll return zero, uh, one. It is working for this. And
It will always
no
work for
what
this case.
to.
You can test it. Like you can directly submit it. No worries. You can directly submit it. You can click on the submit button. You were missing a lot of cases. No problem. Anirudh, you can stop writing the code now because we have exceeded the time. Like it's already
Okay,
been
okay,
1 hour.
okay.
But no problem. So let me stop your stream. Okay. So Anirudh, how was your experience with this mock interview? Like you would like to tell us anything?
It was not
Don't
that
get
great
depressed
actually.
on anything. Don't get depressed. Don't get depressed at all. The first question that I gave you, I was depressed that you have already solved it. But that is why I had to change the question as well. But like I know
Yeah,
that you have solved a lot of problems. Like your resume, since you are still you have started your third year, but your resume looked good.
yeah,
But one thing more that I would like to say, I saw your resume, but you have not made it on something like Overleaf or some latex
yeah, yeah,
latex
yeah.
platform, right? So indentation was not that good in your resume. That is one thing that I will say. And you should
Okay.
start applying for internships. You will get a lot of DSA internships as of now for sure. And you
Yeah,
also
yeah,
have
yeah.
one project in, I think it was React or Node. I am not sure, but it
Yeah,
one
React
project
on
was
React.
yeah, one project was looking good. So for now,
React.
start hunting for internships. You have a lot of potential. I saw your resume. Like starting of third year, it looked really really good. And talking about
Okay,
the
thank you
coming
so
back to
much.
the feedback part. So but you need to change the formatting. Like it will look more attractive. You should try and search for
On the
like
on
let's
the
say roles
resume.
like just you should like it should look more like the spaces are not perfect now you can if you know your resume spaces
Yeah, yeah,
spacing
yeah.
and everything so you can build it on overleaf or latex or on latex
Okay,
or
okay,
something
yeah,
or
yeah,
maybe
okay.
even the Google Doc. That will be fine. And I see like if you have solved so many problems, at least you can start applying for teaching assistant roles in a DSA, or
Sure,
let's say mentor roles, or let's say something like a problem setter role, because you have solved a lot of problems. That so that you're while you're also learning, you also keep on building the experience of organizations and stuff.
sure,
That
sure.
is one thing that I would like to say. Other than this, don't get worried much about the problems. Go back home, try to solve them. And it was really great interviewing you. Like you have a lot of potential. I see a lot of potential in your resume, and hoping to like see that after a few months you will do some internships with some good organizations. As of now, I can see in the resume.
Yeah,
So
I'll
in
try,
the
sir.
third year, try to hunt for some at least some DSA internships, and if you get some SD internships, that will be great. Your resume has a lot of potential. Again, and why I'm saying this, because maybe you will say that interview was not that good, but don't like ups and downs can be there. So no worries for that. Sometimes like the questions we know, but under pressure, it's not easy for solving in front of 150 people
Yeah,
watching you live. It's not that easy. You still had the courage, and this like you still have the GFG t-shirt. You are still wearing the GFD t-shirt that you must have gone by solving the problem of the day. So it shows a lot that you must have solved at least 100, 200 problems daily, continuously, every day one problem. So that's really great. I wish you all the best, and thanks a lot for volunteering. And maybe if you want, after some months, you can come back for the mock interview with us. Okay?
sure, 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 definitely.
Yeah. Uh, Thank you, Anirudh, for
Okay,
giving us
thank
your
you.
time.
Thank you so much.
Okay. Now coming back to the audience, I hope that everyone liked like the question set for today, the problem set for today. Mostly it was based on the FANG companies. And if you want to give the mock interview, then you can find the link of the uh, form link in the description, which you can fill, and then you can directly give the mock interviews with us. It is absolutely free of cost. Someone was asking how much money we will take. We don't take any money. It's all absolutely free of cost. You can directly volunteer, and one of the mentors at GFG will take the mock interviews. Now, if you were still here till the end, so make sure to give us a like to the video and comment down a +1. Thank you everyone for joining, and I wish you all the best. Make sure to keep coding and make sure to keep solving the problem of the days like Anirudh. Bye everyone. Take care. Good night.